I love these related rates problems because you can actually picture a real life thing happening, and you may actually need to understand how to do this. So they give us a cylindrical tank. I like to draw a cylinder like this because that's how you draw a cylinder. And of course that means that it's a circle with a height. So it has a radius and the area of a circle. So I think we can figure out the volume part when we need to. Well, let's see what it says. It has a radius 5, so we'll give it a 5 here. It's being filled with water at a rate of 3 cubic meters per minute. How fast is the height of the water increasing? Well, they give us a couple of things here. They give us a change in volume with a change in time. So that'd be a dV dt equals 3. And we know R equals 5. And the volume of a cylinder is going to be the area of a circle and then times the height. So maybe a way I would want to write that would be pi hr squared like that, because I like having the function out on the end there. So the problem with this is there's no time element here because the volume of something isn't time dependent. It's radius dependent. So let's take the derivative of this here first, and we'll say, okay, dV dr is equal to 2 pi hr. And now, of course, we have a dV dt. What are they asking for? How fast the height of the water is increasing. How do we do that? Well, they want a dH dt, don't they? So we have a dV dt, and we could make a dr dV if we need it. I don't know if we need that. I think instead of dV dr, we might want to do a dV dH. dV dH would be just pi r squared. So we're just basically factoring the h away when we take that. So we could do a dH dV like this. That would cancel that out. It would give us a dH dt. So that would be the inverse of this. So I think what we can do is we can say dH dt. This might be cheating. I don't know that this is how they want to solve it. dV dt they give us is 3. And dH dV is pi r squared. We know r, so that would be 25 pi 1 over 25 pi, because this is the inverse of dH dV. And I think what we're going to end up with is 3 over 25 pi. And if that's correct, then we would get, putting it into the little calculator machine now, 0.0382 meters per minute. And that is the correct answer. So what we've done here is typically you're going to end up doing stuff with the radius. But as we look at the problem, they're asking about the height of the water. So we determined that we're going to want a dH dt, how fast, meaning how much time does it take for the height to change a certain amount. And then we look at the algebra here, and I just inversed the thing that we knew. And at the very end, you plug in your values, and you end up with the correct answer there. Now that one was fun.